Center located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh, joined in building for the first time our new astronomer, and that is Marley Leacock. Hey, Marley, how's it going?
Hi, Michael. I'm good. How are you?
Nice to see you in the building. How have you acclimatized to the left coast over here?
Oh, it wasn't that bad, actually. I was like, hey, it's not snowing anymore. This is pretty great.
Yeah, exactly. So for our family and friends that are still there in Alberta, still having to combat with some of the wintry weather, right?
Yeah, still a little bit. I mean, it is still May, and probably May long weekend it'll come through and snow again. So, but maybe not, but you never know.
All right. Well, let's get going with our hold on. Are we live right now? Hmm. Why does it say our stream is finished? If anyone is watching, just say in the chat. If you're still watching, put into the chat that you are watching. I don't think they are.
My thing still says live on custom streaming service.
Yeah, because that's on shoot. How did this happen? Hey everyone, is anyone watching? Hey everyone, Michael here for the HR MacMillan Space Center. Just having some technical issues. Hey, we do have some people watching. Awesome. Well, let's get going. There had some slight issues. I had to switch over to a different YouTube. Sometimes, this is some of the technical difficulties that we have. But it looks like we do have a class, Shelley Sherwood's Division 6 class in Burnaby watching. So yeah, so if people do find us, so sorry that our YouTube channel had to switch up on you, but you guys all seem smart out there. You found the new channel. So we have some really exciting news stories to get to. Put your questions into the chat, and of course, please be respectful as you do. So Marley, as we are chatting, we do have some weather that we've been observing up there in the sky. Lots of stuff to get to, but our first big story, of course, the big theme for all of this year has been the red planet, and we have some new news from our red neighbor Mars, and it doesn't even have anything to do with NASA. So let's get to our first big story of the day, Marley.
For sure. So yes, we do have a bunch of new news. China becomes, the second quote unquote country to successfully land on Mars. It's a little bit debated because there was a Russian probe that made it to Mars, but it went silent after 110 seconds of being on the surface. So debate on whether or not that counts. But Tianwen-1 did make it and put its a probe onto the red planet recently, this past weekend. So this mission is different from a lot of NASA missions that have gone. In this case, it was an orbiter, lander, and rover combination. So first, they sent up an orbiter, which orbited the planet. Built into that orbiter was the lander, which landed, and then out came the rover from that lander piece. So it launched actually in July 2020 and it reached orbit in February of 2021 and it just landed this weekend. So it is the Jurong Rover. This is a picture of it here. You'll notice it doesn't look like the rovers that NASA has up there, Perseverance and Curiosity. And 3 images have been released so far and will hopefully continue being released through the Chinese National Space Administration as they come in.
Cool. It does actually look a lot like one of NASA's old rovers, doesn't it?
It does. It bears a striking resemblance to Opportunity, and this due to the solar panels on top. So it does have some differences from the current rovers. One of it being the build and how it powers itself, which I do talk about a bit later. But here's kind of where it landed. So this is a map of all of the Mars landing sites. Only America and China have successfully landed on Mars. It's in what is called the Utopia Planitia, which is right around here. It's this big area. Here it's a big basin, and it's about 1,800 kilometers northeast of Perseverance. So it's in a similar area, but still pretty far.
Okay. And so what are some of the main goals of the New China rover?
So it has similar goals to Perseverance's. It wants to look at the rocks and the soil and look for possible water. So that's why they picked the Utopia Planitia, because this big basin may have held an ocean. So this photo here is a photo pretty close to the landing site of Jurong. And so you can see some of the crater formations, and possible up here is a mud volcano that they're interested in. And there have been indications of stores of ice underneath the surface as well. So here's a picture from the Mars Reconnaissance Orbiter, which shows some like sand dune, quote unquote, looking things. So these are interesting features that happen on the surface of Mars due to winds, which geologists are interested in looking at, as well as this is a photo from the Mars Reconnaissance Orbiter. That is not exactly where the Jurong landed, but a little bit to the north of where it landed. And here we see a lot of the ejecta from well-preserved crater impacts in the Utopia Planitia. So Jurong will be looking at things similar to this and analyzing the rock samples in these sorts of formations. And this is just another photo showing different crater cones that they would like to take soil samples from and analyze as well.
Cool.
So this is some of the differences between Jurong and Perseverance. So like I mentioned before, Jurong uses solar panels to power itself, whereas Perseverance uses plutonium-238. And so as the plutonium-238 decays, it produces heat, and using a very special machine, Perseverance turns that heat into electricity to power itself. Because of that, Perseverance is also a lot heavier. Its launch mass was 1,025 kilograms, whereas Jurong has a launch mass of only 240 kilograms. So it's a much lighter robot. But it has a shorter operation as well. Its operation length is only supposed to be about 90 sols, or just about 3 months, whereas Perseverance is supposed to operate for 669 sols, which is a Martian day, or 687 Earth days. And another huge difference is that Perseverance, the orbiter that it communicates with, the Mars Reconnaissance Orbiter, came a lot earlier than Perseverance did, whereas Jurong came with its own orbiter. So that's what makes this mission so incredibly interesting, is that the orbiter, lander, and rover were all sent in one launch.
Wow, this is very ambitious and very cool that we have another country on Mars. Do you know if the China Space Agency, I know that the countries themselves, the United States and China, don't always work that well together at the moment, but what about the space agencies? Do you think that the science teams will be working together on this?
The space agencies have communicated a bit in terms of looking for landing sites and sharing imaging and things like that. And there was a paper published in Nature detailing the goals of the mission, and that goes out to everyone in the scientific community. So there has been some cross-feed of information and some agreements on information and things like that. But it tends to be a little more separate, but it does get shared from time to time.
Okay. Do you have any more information on? Yes, you do. Laser tools.
I do. One more, yeah. So Perseverance and Jurong share, because they share a lot of science objectives, they share a lot of science tools. So they both have that laser tool that you hear about, which is when they zap rocks and look at the chemistry that the rocks are made out of. So Jurong has that as well, and it also has radar to be able to look for subsurface water ice underneath Mars, which Perseverance has on board as well.
Okay, excellent. So, like I said, we've got that class in here. And of course, if anyone else is watching wants to get in on the questions, put them in here. We got tons of questions to get to, Marley. Let's start with the Mars questions first, and then we'll get to our next big story after that. So, let's start with you talked about an orbiter. So, China did send an orbiter back in February, which arrived in that month with all of the other Mars orbiters. But could you define what an orbiter is?
So an orbiter is just the satellite that circles the planet. So like we have the Mars Reconnaissance Orbiter is a really popular orbiter right now. So that is the orbiter that NASA put up around Mars that orbits the planet and communicates with Earth-based communications and also communicates with technologies on the surface of Mars, like the Perseverance rover.
Yeah, excellent. So we did say that they all sort of arrived at the same time in February, but they all blasted off of Earth back in July of 2020. So it took that long to get to Mars. But another question is how far away, I guess, like approximately, I don't know if you know the exact distance in kilometers, but could you give us like a little bit more detail on how far away Mars is?
Yeah, so the launches for Mars, the reason they kind of happened in that July window, I think the Chinese mission launched, the Perseverance mission launched, and another mission by the United Arab Emirates also launched in that time, is because that was the window where Mars would be closest to Earth. So that's why they all seem to cluster together. So I don't know the distance off the top of my head, but it does change from time to time. But it is pretty far. About on average, it would take an 8 months to get there in terms of time, how far away it is.
Okay, so we're talking about a pretty long road trip, is what you're saying, and we can't exactly open the window to get some fresh air, right?
No, 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 not at all. It is okay. Looking up, apparently it's about 300 million kilometers from Earth, but that will depend. That changes depending on where Earth is and where Mars is in relation to each other.
Okay, well let's talk about humans getting to Mars because we are getting some questions about that. At the moment, can humans live on Mars?
At the moment, no, we can't live on Mars. The atmosphere is incredibly thin, and there's not a lot of oxygen for us to breathe. It also gets incredibly cold at night on Mars because of that thin atmosphere doesn't hold any of the heat in very well, and it's much further from the sun than Earth. So currently, just the robots are able to live there, and even then, there are some struggles with the robots. You remember when Opportunity was no longer in service? They think it was maybe a sandstorm covering the solar panels, and so it got to a point where it could not keep itself warm and shut down. Possibly, there's still problems to this day with the robots. So until the robots are doing things a-okay, and until we find a way to breathe on the surface, I don't think we'll be there in the way we are on Earth anytime soon.
Right. So that's living. But we do also have some questions about maybe just going, like astronauts go to the moon. We do have spacesuit technology. So is that possible? Can we get astronauts just to walk around for a bit on the surface of Mars?
Yeah, that's actually NASA's one of the main things NASA's looking at right now. So the Moon to Mars initiative that NASA launched just earlier these past few months has been targeted to try to get astronauts on Mars by I think late 2030s. I think is their window for getting people there. And so they actually have designed new spacesuits specifically for this type of motion, but first they're going to test all of that on the moon. So in the late 2030s, NASA is expecting to put astronauts back on the surface of the moon. And then through that, building what's called the Lunar Gateway, which Canada will play a role in developing, providing robotics technologies, and then hopefully Mars. So Mars 2030, hopefully astronauts will be there late 2030s, but the moon will come first.
And do you have like sort of like an astronomer best guess of when we're going to get to the moon?
Moon, I think they were estimating to have people back on the moon in the late 2020s, so sometime within the next decade or so.
Okay, so for all of the classes that are watching right now, you'll likely might be at the end of your schooling, maybe in high school by the time that we get some humans back on the surface of the moon and to Mars, which means by the time that you get a meeting to get into university, maybe you could start applying to be the next astronaut. Definitely going to be looking for more of those people, or maybe not an astronaut per se, but maybe working on some of these cool robots because these are just the first stages, and as we can see we keep evolving better, bigger, flying around like we are on Mars. Very cool stuff. There was another question from another class, actually in the same class. Division 6 in Burnaby, about the plutonium. So the plutonium, is it radioactive?
It is radioactive. So that's what I meant by as it decays. So it undergoes radioactive decay. And using a special machine that was developed by the military, I think, the machine takes the heat that's sent out from that decay, radioactive decay, and turns that into electricity to power Perseverance. So it doesn't need to rely on solar panels.
Okay. And one last question about Mars is that you had talked about some of the ancient lava flows, so like geologically. So if you tab back on some of those images, we can have a look at what you were talking about there. Yeah, Utopia Planitia.
Yeah.
So does that mean that there were active volcanoes? Like, was there lava there on Mars?
So Mars is like geologically active. So what they were looking about here is what's called a mud volcano. So not a volcano like lava that like we see on Earth whenever a volcano explodes, but more it was mud. And so they call it sedimentary volcanism. So it's like liquid mud. So really, really water rich sediment that ruptures from the subsurface of Mars and it flows like lava does here on Earth. And so they're very interested in that and the geological processes behind that.
Okay. So definitely going. And one more thing I just wanted to point out, because on this picture, it's a really cool photograph. And you're like, wait a minute, are
Yes.
we looking at Mars? I thought that Mars was red. What exactly are we looking at here with this green Mars?
Yes, no, sorry. These are two false color images layered over each other. So it's not. This is not what Mars looks like. It's not green and blue. It's just the what was used to take the photograph and what they were looking at. But I picked this picture specifically to highlight this interesting little feature up here.
So when we do look at pictures like this, and scientists do use photos like this, what is this false color really showing us? Just is it altitude?
Yeah, it can range. So I think this one was elevation, different
Elevation. Okay.
elevations, and different things like that. Yeah, but it can change from depending on what they've defined it to be.
Okay, excellent. If you have any more questions about Mars, we'll get to those. But we're going to transition to our next big story because, of course, as we just said, Mars is pretty far ways away. We're not going there anytime soon. Hopefully, you in the future. But there is something that you can see with your own eyes coming up in the next week. Speaking of worlds that are red, our very familiar moon is going to be turning this very pretty, I want to call it like a crimson red, almost like a pinkish hue. Tell us about the total lunar eclipse, Marley.
Yes, so the total lunar eclipse is going to be happening May 26th, and its maximum is going to be at 4:18 in the morning. To be able to see it, you're going to want to look in the southwest and have a clear view of the horizon, since it is going to be very low on the horizon as the moon is setting during this time. So you may have heard it being called a bunch of names like the super flower blood moon or like the super moon eclipse and things like that. So a super moon is just when the moon appears to be larger. And this will we usually when super moon is mentioned, it's usually talking about a full moon at perigee. And perigee is the closest the moon comes to Earth in its orbit. So this picture here shows a comparison between the normal moon on December 20th, 2010, a normal full moon, and the super moon on March 19th, 2011, just to give an idea of how much larger it looks in the sky. Supermoon is not a technical term, but I think it's a good one because it gives you the idea pretty well. This is called perigee syzygy, which is a Greek word, but it just means when everything is in a line, which happens once or twice. So this is the perigee syzygy. So when something is in a line and the moon is at its closest approach to Earth.
All right, everyone watching, I want you all to say perigee syzygy out loud on a count of three. 1, 2, 3. Perigee syzygy.
Syzygy. Yeah, it's a very long term. It can also be said like perigee syzygy of the Earth, Moon, Sun system, which is just a mouthful. So supermoon works really, really well for describing this, I think. So this is what happens in a lunar eclipse. So this is not to scale. And this is from timeanddate.com. You can check them out. They have a really great explanation of this as well. And so the Earth passes between the sun and the moon all in a line. And the moon, as we move, our shadow covers the moon's surface. And the reason it goes this red color or the blood moon is because even though Earth is blocking out the sun's light from hitting the moon directly, the light passes through our atmosphere and hits the moon. And there's something called, it's called Rayleigh scattering. Hope I pronounced that right. Yeah, Rayleigh scattering. And so what this is this equation here. So scattering is proportional to 1 over the wavelength to the power of 4. So this means that really, really small wavelengths like blue light and things like that are scattered more strongly. And so when we have our very large wavelengths, they are not scattered as much. And long wavelengths tend to be things that are red or orange. And so the moon appears to be red because that light is not shot out in different directions. It's able to stay on its path. And this is just a really cool photo that I like that shows the lunar eclipse as it happens. So this was taken by Keith Burns in a contest hosted by NASA to create like a NASA wallpaper. So he took these photos, and as we see here, this is the moon at its full moon in its phase, and the Earth's shadow does start to cover it. And when it is fully covered, we get this very beautiful red moon at the end of it.
Well, what's really interesting about this photo, Marley, is that this photo was all taken in one night. It's almost as if like we're watching the moon go through its phases, which takes an entire month. And when the moon is going into the Earth's shadow, that's not the same as when the moon is up there in the sky and it's a quarter moon. The black part of it is not the shadow of the Earth. That's just the angle of the sun on the moon, right?
Yeah, it is. So it is different, even though it looks very similar. Yeah, phases
Yeah.
are different. Has nothing to do with the Earth shadow at all.
Interesting. And then when it finally does get into that full shadow, like it's almost as if that color, I would almost even equate it to maybe like a sunsetty color, which is very similar. Like when the sun is setting, the sky does sort of turn that sort of deeper red, right?
Yeah, it does. And that's also attributed to Rayleigh scattering. So it's the same phenomenon that happens that turns the moon red is how we get like the sunset colors as well, even though you have to toss air pollution in on that one, but it is the same mechanism.
Right. Now you did say did you say 4:21 a.m. or was it 4:31?
418 is the maximum. Yeah.
4:18. So that's Pacific time. So that's people that are here in Vancouver. But what about, I know that we do have, you and I both have some relatives in Alberta watching. So for people in Alberta, perhaps people in the eastern part of the country, will they be able to see it as well?
Yeah. So this is a map from timeanddate.com showing the eclipse visibility. So this legend here is based on color, entire eclipse is visible, going to not visible at all. So unfortunately, all the way on the East Coast, in Newfoundland and parts of the Maritimes, you are not going to be able to see the eclipse at all. People kind of in the Alberta region, Calgary, Edmonton, may be able to see some of it, but it will be weather dependent, and its maximum will be at 5:18 what is mountain time, I think they use. And as it goes out more east, the harder it becomes to see.
Right.
Yeah.
And of
So
course, as you go
no, go
further
ahead.
east, it is going to be really into that western region right before sunset, right?
Yeah, and even us over here in Vancouver are not going to see the total eclipse as they defined it. So we will see it turn red. But as it starts to come out of the Earth's shadow, as it starts to turn back, quote unquote, to the normal moon, the moon will actually set below the horizon. So even us in Vancouver won't be able to see the entire event happen.
Right. But if we do go out and do have a good, clear view to the west, we will be able to see it, right?
We will be able to see it provided that you have a clear view of the horizon because
Right.
it's going to be very, very low. So you're going to want to look towards the southwest with a clear view of the horizon here in Vancouver.
Yeah, and maybe like a good thing that you could do is if you're unsure, and this of course is for actually even for people in Alberta as well, is that over the next couple nights, if you do see the moon, if you look at the moon set, maybe look to sort of see where the moon is setting, and you can maybe go to your backyard and see like, do I actually have a view close to the horizon, or where would you potentially go? So for myself, I live in Kitsilano here. I might go down to the beach because I know it has a clear view out to the west there. So wherever you live, maybe have a look to see where the moon is setting the next few nights and to see if you can catch it.
Yeah, that's a great idea because it is very cool to see. I think the last one was several years ago that was visible from here. So it doesn't happen as often as we'd like it to.
All right, so we got a few more minutes. Let's get to a few questions here. So, of course, we had a big solar eclipse happen a few years ago here, Marley. But we don't need any special glasses to view this eclipse, right?
No, this one's totally safe to view with just your eyes, for sure. You'll be fine.
Right. We are looking at the moon like we normally do, reflecting light and even less light, I suppose. Like the brightness is actually dimming down too, because that light is not directly hitting the surface of the moon, right?
Yeah. So it's not like looking at the sun at all. It's, yeah, in fact, like you said, it's light that's passing through our atmosphere, hitting the moon, and then coming back that we're looking at. So it will be dimmer than normal.
Awesome. All right, let's get back to some rapid fire questions. Some on Mars, some on the moon, some, grab bag of space potpourri. Okay, let's start with the sun. We are talking about the sun. Can the
Mhm.
sun move?
Can the
Pretty
sun
interesting.
move? So
Yeah.
the sun is moving. Currently, the sun both rotates on its own axis and also goes through its own movement through the arm of the galaxy that we are in. Most of the phenomenon when we talk about solar eclipses or lunar eclipses, we use Earth as a reference frame. So we talk about Earth moving into the path of something else, but it is the sun is currently moving. Yeah.
Yeah, excellent. So let's stick with the sun and the moon. So when we're looking at the moon, and we showed us, if you go back to that picture of the lunar eclipses and the different phases there, that side of the moon is always the same side that we see, right, Marley?
Yes, it is.
So what does the other side look like? If we only see one side of it, what's going on the other side of the moon?
It looks pretty much the same. There are photos of the quote unquote dark side of the moon. What how this works is that the moon and Earth are locked together. So when the moon orbits on its axis, it actually does that at the same speed it does as it orbits Earth. So that's why we only see one side of it. And so when it is a new moon, when we see a new moon and it's completely black, the other side is actually completely illuminated by the sun. So there have been photos taken by different spacecraft of that side while it has been illuminated.
Right. So not the dark side, the far side of the moon,
The
right?
far side of the moon, yes, not the far side that we don't see. Yeah.
Excellent question from another grade 6 class watching. Let's go back to Mars. So we talked about, so our human are going to Mars, but no human has got there yet, correct?
Correct. Yeah.
Okay. So hopefully soon we'll get some humans there, as either be NASA, maybe Elon Musk. They're both racing there, hopefully around 2030. Now, the space in between the planets. So we have, when we see a picture of the planets in our solar system, it seems like there's a lot of blackness, nothingness in there. Is that pretty much all there is? Is there just a big bunch of space in between the planets?
Yeah, so space is incredibly big, and on a scales that I even have a hard time understanding. So there is actually quite a lot of empty space, despite all of the things that we see. And you see pictures from Hubble of like all these galaxies put together and lots of bright stars. There is actually a lot of space in between the planets.
Yeah. A lot of space in space,
In space, yes.
which is why it takes a long time to get anywhere, right?
Yeah.
Um, what about asteroids? Because we haven't talked about asteroids yet here. We will soon next month. We're going to have a whole focus, actually, a whole month of June. We actually become, you could actually help us make a comment. You guys are going to, you folks are going to be able to come and study rocks and think about the rocks that are in space. So all next month, you should come visit us. But let's think about those rocks, because they are sometimes in between the planets and we have visited them. So are there any realistic plans to mine asteroids? We've heard that term in the past, but where are we at right now with that?
So recently, if I'm remembering correctly, Osiris Rex, I think, is actually returning, if that's the right mission. There is a mission that's
Hmm.
returning to Earth with
Yep.
asteroid samples. And there are more to go in the future to go. Different space agencies are doing it to land on asteroids that are close and take samples of the core of these asteroids to see what they're made out of, predominantly. So that is something that is currently happening and continues to happen as well.
Excellent. So we've got just a couple of minutes left. There will only one thing that I will mention. Again, of course, lunar eclipse. If you do go out, maybe try to take a photo of it and send it to us. You can hit us up on our socials at Space Center YVR. just looking to see if we got one last question. Let's go back to our grade 6 class. If you were to approach the sun, how close would you have to be before you would burn? That's a classic grade 6 question right there.
That is, yeah. So probably further away than you'd think, and it depends if you're doing burning from heat or burning from radiation. So the sun is consistently putting out particles in like solar wind, which are highly charged particles and ionizing radiation that could cause problems for you at different times than the heat would cause problems for you. So I'm gonna say, look up which one do you mean, and then ask me again next time.
Exactly. And if you do want to learn more about getting close to the sun, the Parker Solar Probe, which is a spacecraft that is in orbit around the sun, it is getting closer and closer. And each time that it does another pass, it breaks records for the closest human-made object to get to the sun. So you can look up that progress. It's kind of orbiting around the sun and Venus, right?
Yeah, it is right now. And if I'm the Parker Solar Probe, it actually passes through part of the sun's atmosphere called the corona. That white bit that we see on solar eclipses during solar eclipses is what it's actually passing through each time, because scientists are very interested on how the corona works and why it is so hot. So definitely look up the Parker Solar Probe to learn more about that.
Absolutely. And of course, if you are, venturing out into space, maybe don't go too close to the sun. It's really hot.
It's
You don't
really
even have
hot
to
and
go.
very bright.
You don't even have to go that close to the sun to get it really hot. Just be in the sun, because remember, in space, if you are directly in the sunlight, there's no atmosphere to shield you. So not only is it going to be hot, there's going to be a lot of radiation as well. So
Yes, if we
lots
can
of
get
things to look out
sunburns
for.
being on Earth with our protective atmosphere and sunscreen, being in outside with just space is going to be a lot worse.
Yeah, even if we had those protective eclipse glasses on, they wouldn't help us.
No.
One last question. I know that we got a bit of a late start. Thank you everyone for your patience for finding the new YouTube page. But Jacob gets in here with a question. Just a small question to end us off here, Marley. What is dark matter?
Oh, yeah. That's a really good question. I would love to have an answer for you. It's something that's there that we can't see, but based on a lot of math that different scientists have done, it should be there holding things together. We just can't seem to find it.
That's a good answer. Marley's kind of the classic, we don't know, but we're working towards, and we're getting closer to the answer, hopefully. And you know what? October 31st is a special day. Some people may call it Halloween, but it's also Dark Matter Day. So we are actually going to do a whole series in October. So if you're interested in learning more about dark matter in October, and actually in and around those dates, we'll be focusing in on dark matter. Well, Marley, thank you so much. This has been a successful, hopefully a little bit of a hesitant start. That was on me. That was my fault. You did a great job. But thank you all so much for the two classes that we had joined. We will be live here on YouTube in 2 weeks on YouTube, same channel. On Thursday at 2 p.m. And like I said, we are open Thursday to Monday. You can go onto our website, spacecenter.ca. You can book yourself a time to visit. On Thursdays and Fridays, we use our telescope. Today, we're doing solar viewing. Tomorrow night, we'll be maybe looking at the moon, with our telescopes. And then on the weekends, we do activities. You can look through our gallery space. You can come, you can build your own lunar lander, give you an egg, and then we'll drop it and see if your lunar lander will survive. So there is some fun activities to be had. Check us out on our website and come visit us. Until next time, take care, everyone.
Bye.